Hi, thank you very much, Dirk, and thank you, Gabrielle, for a fascinating talk. I'm just about to share my screen, and here we go. So my background is different from Gabrielle. I guess that's the idea, is there's a synergy here of some kind. I'm a social scientist. I've been working partly in government scientific advisory committees, more on the epizootic side. And I'm not a modeler, so that's the first thing, but I'm interested in the way in which knowledge and different kinds of issues get formatted within the policy environment. And of course, modeling is part of that, and a very constructive and important part of that. So I'd just like to start, and Gabrielle's already talked about some of the history of modeling. We can go back to Ronald Ross, for example, and his understanding of the role of mosquitoes in the transmission of malaria, and of course the important interventions that he started to model, not the first application of mathematics and modeling to epidemiology, but one of the key ones. And then, given the number of Australians on this project, also I should mention Frank Fenner, whose role in the experiments over myxomatosis, for example, in Australia, and the modeling of that process of susceptible and recovered or resistant rabbits was key in the uptake of some of the most commonly used types of models, the compartmental models that were of course taken up by Robert May and so on, and then worked through into some of the imperial models and so on that we've already heard about. So these are key, partly because I just wanted to emphasize that some social scientists are very suspicious of the use of these models because they come from ecological ways of thinking, if you like. And recently the historian Warwick Anderson, based in Sydney, said, what might be lost and what might be gained when human populations are remodeled as, he said, vermin? So we need to think about that. But the key is what might be gained and what might be lost. And I think there's some key issues here to think about. Very obviously, and just Epi 101 from a book we did a few years ago, Pathological Lives, and of course it's a key one for thinking. Of course, infectious diseases are relational. Everybody knows, I hope, on this call, on this conference, that there are a relation between hosts, pathogens and environments, and of course epidemiological models are really dynamic mathematical expressions of those kinds of relationships. The important point though is they are relationships, okay? It's not just the contaminant or the pathogen that's important, it's not just the spark, it's the fuel that is part of that forest fire. And I think that's why the social sciences are really important in thinking about the configuration of disease susceptibilities, if you like, not just the transmission processes involved. And that's a really key point that I want to keep coming back to. So some of the complexities around models, and I think Gabrielle's done this very well already, but of course there are a whole series of models and thinking about complexities, and his graphics were really useful. I won't go into them in great detail, but we have the compartmental deterministic models, which tend to use heterogeneities, let's call them unknowns and variants, for example, unknown transmission rates, particularly early on in a pandemic, latency, age-related susceptibilities, fatality rates, and so on. These can be relatively unknown at different stages of the process and have to be allowed for in these deterministic models. Some of the stochastic models, the ones that deal with more chance occurrences, of course, produce a range of values which can be very useful to give you the kinds of error bars that we associate, or uncertainties associated with these models. Agent-based models can code for individual behaviors rather than using population kind of characteristics or norms. We can start to put in codes to determine or to model the ways in which particular individuals move around and so on. And then ensemble models from climate change, I guess, is running multiple versions of models to stress test them and so on. And of course, all of these things add complexity and sometimes reduce the efficacy or tractability of the results in terms of the policy world. So for example, there are these trade-offs, and Andrea Saltelli's work is really, and her colleagues are really important here in thinking about this. And there's a nice little infographic at the bottom there. Complexity can increase adequacy, as Gabrielle showed very well, But you can risk propagation errors as well and make models inscrutable, or they become like a black box, difficult to, especially for policymakers and social scientists like me, to understand some of the processes involved. Simplicity, on the other hand, increases agility and transparency, but of course, as we've seen, can produce false precision. We can get the frog rather than the, or the toad rather than the butterfly, as Gabrielle suggested. So a very useful infographic there from Andrea Saltelli. So I just want to talk a little bit about the social, and I guess that's why I'm here. I don't think it's just modelling at all. It's in policy terms, and I've noticed over a few years of advising on various committees, in policy terms and in modelling terms to an extent, the social tends to be formatted as something called behaviour. So we get this all the time in the UK situation, but I suspect elsewhere is that as a social science, you're drawn into talking about behaviour. That tends to mean what kinds of contacts are people making, what are their contact-related behaviours, and the estimates of compliance. And that tend to be how social science is formatted in these kinds of fora. And I really want to be emphasising that social science, of course, does a lot more than that, and there's a lot more complexity to the social than behaviour, and we don't want to reduce all human experience to these behaviours. One example we could take recently from the UK, one of our real problems has been over the susceptibilities and vulnerabilities of care homes. And I just want to sort of mention a few issues here around care homes. The issue, for example, and often we think in terms of processes and infrastructure when we're talking about the vulnerability or precarity of certain kinds of settings, and some of the things that I've listed there, one of the reasons that care homes became a particular problem in the UK, but also elsewhere, was the governance and management of those. We had thousands of providers, difficult communications, the cultural and practical norms around care and physical contact associated with care. And of course, this refers back to the modelling and understanding of the cultural drivers of transmission in the Ebola cases that we've had, epidemics in recent years. And then infrastructure, sector fragmentation, poor supply of personal protection equipment, inadequate buildings, poor pay, economic precarity, and particularly agency staff, which was a real surprise to the modellers, that the agency staff were moving between sites. And one of the consequences, I guess, of a decade or so of austerity in this country is that we have particular kinds of working relationships which make these kinds of structural drivers of transmission and vulnerability or precarity more important. And I should say we've got one of the largest avian influenza epizootics in this country, in my country, in the UK at the moment, and elsewhere, of course. And we've come up with very similar. You could actually use that list for the outbreaks on commercial farms in the UK. Very similar issues of poor infrastructure and so on. So it's more than behaviour. There's a lot more to these kinds of issues. We've done some work in Bangladesh, and I just wanted to mention that because I know lots of people in this hub are doing similar kinds of work of participatory modelling, getting people to kind of write down the kind of real drivers of disease and also antimicrobial resistance, and using some heuristic modelling devices with aquaculture workers in the bottom left corner there to try and develop these kind of more participatory models, which may be one way through some of this complexity and increasing the social aspects of it. So I want to end with a manifesto, go back to Andrea Saltelli's work, who recently published a manifesto last summer for thinking about all models, and this was about climate and dealing with waste, radioactive waste, all kinds of issues. But just a couple of things to highlight here, and then I want to add something to them. First of all, modelers must not be permitted to project more certainty than their models deserve, and politicians must not be allowed to offload accountability to models of their choosing. And we face this kind of suspicion and lack of trust in the UK in particular, when politicians argued they were following the science. And it really led to a kind of debate over, and I think modelers being put in really awkward positions by their politicians in this case. So we need to be really careful about what models do. They offer insights, as Chris Whitty, the chief medical officer in this country, has argued. So mathematical is a great way to explore questions. There are also dangerous ways to assert answers. Asking models for certainty or consensus is more a sign of the difficulties in making controversial decisions than it is a solution, and it can invite ritualistic use of quantification. And I think that's key. They are part of a set of decision-making procedures. So one thing that I would argue is that we need to get better at building diverse assemblies, going back to what the discussion we just had around the role, the policy environment. How do we build these diverse assemblies so that we get the voices of those, for example, in Bangladesh, who know about what's going on in their village when it comes to poultry disease or anything else, but also the social scientists who may know about care homes and so on. So 4 quick points. We need a diverse assembly where insights, including model insights, are possible from a range of knowledge practices. These knowledge practices need to work with pre-existing hierarchies and without pre-existing hierarchies and without the burden of integration. So not all knowledge can be incorporated into models. Models, of course, can do a lot, but they can't incorporate all knowledge. The relational complexities configuring infectious disease are as important as the dynamics of contamination. And then this is probably my key point, and one from the limited experience I have in the policy world, is that we may need a new mode of practice for expertise, from that kind of assured expert who defends their corner and their discipline to conditional spokespeople for specific associations. And they may be a virologist talking about her viruses in the lab to modelers and mathematicians and so on, talking about the propensities and abilities of models to provide insight, but also then sociologists and others who can talk about some of the drivers of vulnerability and so on to disease. I will stop there.